some professor at some institutions. So can I get introduced with one or two participants so that I can understand because like I should understand the level of the audience also so that I can deliver in that way only. So, for example, this Mr. Paramjit Singh, good evening. Are you able to listen me? Paramjit Singh ji? Okay. Is Mr. Rohit Gupta? Are you able to? Yeah. Can you introduce please yourself for just a moment? Like I just want to know that from which place you are. No, you are muted actually.
Sir, myself Rohit Gupta. I'm assistant professor in Government College for Women, Gandhinagar, Jammu, and my subject is computer application.
Computer application. So you have done your PhD from which place?
No, I have not done PhD. I have done masters in computer application.
Masters.
I'm presently doing research in this PhD from University of Jammu.
Okay. Thank you. Dr. Siddiqui Lubana is there. Dr. Siddiqui, Dr. Ruby Kaplial. Because like when
Good evening, this is Dr. Ruby Mamgai sir from Government Degree College, Bhupatwala, Haridwar, Uttarakhand. And sir, I'm assistant professor from Department Education. And sir, I have done my PhD from Jivaji University, Gwalior, sir.
Okay, Jivaji University, Gwalior. Okay. In which year you completed? So in which year you have completed your PhD and what is your research domain?
Sorry, sir. Sir, my subject the inclusive education, sir. जो मेरे टॉपिक है सर, जो PhD मैंने किया है वो डिसेबल्ड पॉपुलेशन पे सर मैंने किया है कि मेन स्ट्रीमिंग ऑफ दिस डिसेबल्ड पॉपुलेशन.
Okay, so anyone from this audience, thank you very much, Dr. Ruby, for giving your introduction. Okay, anyone who else has completed the PhD program? How many? I just want to know that how many are PhD candidates? They have done their PhD. Okay. Dr. Kapil Gupta.
Yes, sir. Good afternoon, sir.
Good afternoon.
This is Dr. Kapil Gupta from IIT University, Lucknow. And my PhD is in image processing from brain tumor detection.
Okay. So you have basically worked with neural networks?
Computer science engineering discipline. And in this discipline, image processing is the area of specialization, and the topic is around the brain tumor detection.
Great. Thank you very much. Yeah. Anyone else like this? Dr. Purna C.H. Sethi.
Yes, sir. Yeah. I am from Ramadeva Women's University, Bhubaneswar. I have completed my PhD in Information Security and Network Quality of Service from Utkal University, Odisha.
Great. Thank you very much. Anyone else who is? Why I am asking? Because like we are having 3-hour session. And before delivering my lecture, because like if I will deliver, I just want to understand that what kind of audience I am having. Because if I will bombard you with so many mathematical models and other things, then it is not justifying if I'm not able to understand that who are the audience. By the way, it has been told to me that it is a faculty development program, but it is not always guaranteed that in the faculty development program, all the candidates are PhD holders. So it might be that somebody is doing after masters, they are doing this job of teaching. So I just want to understand that. But by the way, I came to know that at what level I have to go. So let me share my screen and then we will proceed with the talk. Only one question is, like request is to you all, that if you are facing any kind of problem during the presentation, because it might be that I will go more deeper into the technical contents. So if you are facing any kind of issue, you immediately ask me the question. Okay, don't feel like any kind of hesitation. Don't feel any kind of hesitation. Okay, because if you will not ask the questions, you will lose the like contents. I'm not going to lose the content. Okay, so that is my request to you. Okay, so let me share my screen and we will proceed with the. So, are you able to see my screen?
Yes, sir.
No, sir.
Thank you. Thank you for the confirmation. Okay, so basically what I have been asked that I have to tell supervised machine learning, unsupervised machine learning. So first I just want to go into one of the distributed learning mechanism for the edge networks, for the IoT applications. So you can see the title of this particular talk is Energy Efficient and Latency Aware Blockchain Enabled Federated Learning for Edge Networks. So what this title is telling to you, the title is telling to you that we are going to work with edge networks. So how many of you are aware about edge networks? That what is an edge network? How many of anyone who is aware? And please don't hesitate. If you are telling something wrong also, it does not matter. I just want to understand, because if I will not be able to understand, then I will not be able to explain you. So anyone who is aware about edge network, that what is edge network? If you will not reply in a single minute, then I will assume that you are not aware about these things, and then I will go into more deeper. Because if you are not understanding a word properly of the title, then it means that I have to explain these things. So edge networks. Anyone who is aware about edge networks?
Hello.
Yeah.
Sir, edge network is very close to the edge devices like mobile phone and or laptop or the other devices that user directly operate. So.
Actually, you are like very much correct. So edge network basically, when we are bringing servers closer to the devices, and we are processing the data of the devices over very close to them, then such kind of architecture of the network is basically going to be called as edge networks. And now I believe that you are able to understand. So what I just want to tell you that when you are generating some of the data can be processed over the cloud, over the fog, over the cloud server, over the fog server, or over the edge servers. So when you are processing the data very close to the devices, then we are talking about edge networks. This part is clear to you? Only where the server is placed to process the data of the devices, that is basically that is going to change the terminology to cloud network or a fog network or edge network. So I believe now, and this edge network is basically we are talking about Internet of Things. We are talking about Internet of Things, and the data is going to be processed very close to the devices. Now, anyone who is aware about federated learning?
Sir, how to identify the property? Means whether it is satisfying the property or it is calculated by distance or any other parameter? Hello?
Not yet. Hello.
Hello.
Yeah.
Hello.
Yeah, actually your voice is not
sir,
clear.
how to identify, how to calculate the distance, how to calculate whether it is close. So close means what? In terms of which parameter this closeness property is identified?
Yeah, you can say that suppose, for example, when you are talking about communication. So communication is all about the range of communication. For example, you are talking about Zigbee protocol. Suppose IEEE 802.15.4. Then you will always talk about a distance of transmission within a range of 20 meters. And that is the reason you will basically say that it is a multi-hub communication framework. When you are talking about LTE communication, or you are going to talk about LP-WAN technology or LoRa communication, then you will talk about in kilometers. Like directly the data can be transmitted to the devices in the range of 4 kilometer, 5 kilometer directly following the star topology. So the edge networks is basically when you are talking about, when I'm telling that the devices are closer to where the servers are closer to the devices, it means that we are talking about the distance. So distance in the sense like rather than transmitting over the long distance, because you also, if you have researched in the area of this Internet of Things or wireless sensor network, you know that when I will transmit the data beyond a certain threshold, then the energy consumption of the device will be at the rate of d power 4. While if you are transmitting the data below a certain threshold, then the energy consumption of the device will take place at the rate of d square. So distance is very much related to this what you are telling, that quantifying, how you are quantifying. So distance is going to play a very crucial role when you are going to design the architecture for in the context of edge network or fog network or cloud network. Is it clear?
Yes, sir.
Are you able to listen me?
Yes, sir. Yes, sir. Understood. Thank you.
So, am I? You are able to understand the like answer of your question?
Yes, sir.
Yeah. So the second term is this federated learning. So what is the meaning of federated learning? So federated learning is basically the federated learning means you are doing the training process locally rather than globally, and on the individual device you will train the model, and the model parameters will be transmitted to the cloud server, and you will apply some of the techniques, either fed average or fed SGD, or many techniques are there, and you will take the you will get a convergence of the model, and then again those converged model parameters will be sent back to the devices, and again the devices will train their data on that particular converged model parameters. So this is basically the concept of federated learning. So what basically federated learning is, in case of cloud computing, basically you will take all the data and you will apply this machine learning, or you will do this artificial neural network modeling over the cloud server for the whole data, and you will get the classification, some precision, accuracy, precision, recall, F1 score, all those values you will get. But rather than training the cloud, training the data over the cloud, if you are partially, you are taking certain amount of the data and you are locally doing the training process, then this process is basically going to be called as federated learning. Now, are you able to understand the meaning of federated learning? So if you will say yes, then I will proceed, because otherwise there is no point. I will speak so many technical things, and you will waste your time. So even we will understand very less concept, but we will understand nicely. That is the point actually. So this federated learning, any difficulty, you are able to understand that what is the meaning of federated learning? Actually, if you will not respond, then it will be difficult for me to proceed further.
Yes, sir, I understood.
Yeah. So you please say yes or no. Otherwise, I will, because if you will not say yes or no, I will be stuck. Okay.
Yes,
So,
sir,
yeah.
can you repeat it once again? What is
this
federated learning? Federated learning.
Yeah, federated learning is basically what is happening. Suppose, what do you understand by cloud, learning on the cloud? So learning on the cloud means what basically learning you are doing? You are having a data set and you are training a particular model. You are developing a particular model and the model is learning their weight and biases and this model will be updated and ultimately you will get certain classification on that particular data set, right? Certain precision, accuracy, recall, F1 score, all those values you will get. But you will do these things over the whole data. That is basically cloud learning on the cloud. Now, federated learning, because I am talking to you about edge networks. So edge networks means you are bringing servers closer to the devices. And what you are basically doing to individual server, you are associating certain devices, not all the devices you are associating. So a part or a portion of the data you will get only over the devices, and on that particular amount of the data you are going to do the training process. So you are not having the entire data, you are having a partial amount of the data, and this partial, when you will add all the partial, all the small amount of the data, then you will get the whole data. So rather than training over the whole data, you are training the model over a small amount of the data. And what is going to happen? You are, after training all the servers, all the S servers, they will send their trained model parameters to the cloud. Cloud will apply certain mechanism to get the convergence of the model parameters. And again, the model parameters will be downloaded by the devices. And again, the training process will be started. And this training process will be started, it will be done in iterative manner in multiple times. And ultimately, the federated learning model will get almost equal accuracy, precision, and recall values when you will do the training over the cloud. You are able to understand now?
Sir, actually, that means, we have some, let's say, various samples of the data, and it is being trained on different machines in a distributed manner. So when we are going to converge it, so I think convergence will have some issue, or what will be the mechanism?
Mechanism, I'm telling you, mechanism you just understand in this way, that suppose you are having three servers, A, B, and C.
Yes, sir.
Okay, they are the S servers, and you are having a particular cloud server that is D. Suppose that is D. Now you can train the model over D alone with all the data, and you can do 1/3 data to A, 1/3 data to B, 1/3 data to C. And when you will do the training with 1/3 data, then the trained model parameters will be sent to D. A will also send the trained model parameters to D, B will also send to D, C will also send to D. And at D, certain various mechanisms, for example, Fed average is there, Fed SGD is there, Fed various mechanisms are there. And through that, you will do this convergence of the model. Like A is telling this is the model, this is the best model, B is telling that this is the best model, C is telling that this is the best model. But after collecting these models, D will decide that what should be the converged model, and again the converged model parameters will be again sent back from D to A, D to B, D to C.
Okay, sir, I have another question, another doubt, in fact, in my mind. That suppose that when data is shared to the respective machines A, B, C, and they are using different models to train the data. Will it be same model, or
they will use the same model, because what is happening? you cannot compare kilogram with liter, right?
Yes, but actually, suppose that some machine is using support vector machine, or maybe another one is using type-based classifier, and another one is using, but the purpose is same. I mean, it is not like kilogram and meter. They are,
No, the purpose is same. That is fine. The purpose is same. But what is happening when you are talking about converged model? So if the model, if you are using different models, then how you will converge on a particular? Because then the complete, where somebody is doing CNN, somebody is doing YOLO, then it is very difficult to tell them that what should be your. So all the servers, they will use the same model.
So just, sir, one thing, then what will be the benefit of it? Because models are same, I mean, classifiers are same, and they are being trained. So rather than using the three machines, one machine can be sufficient.
Yes, so that is the agenda of today's talk. That is the agenda of today's talk. Now see, when you suppose you don't have a system which is having 128 GB RAM. Suppose you are having 3 laptops which is having 16 GB RAM. Now you want to execute the task of training 500 GB data, then is it possible for you? No, it is not possible for you. So you want to validate that this, if I can break down this particular data, then your machine will be able to handle. Your machines will be able to handle. So there are certain applications where you cannot train the whole data on a particular location. For example, if you are supplying your whole data on the central server, then there is a chances of data breaches. There is a chances of high performance computing, requirement of high performance computing system. There are chances of transferring the whole amount of the data, which will consume a lot of energy. It will require a lot of time for the network. So there are various, not one or two, there are plenty of challenges due to which we want to break down the data and we want to learn the model parameters closer to the devices.
Yes, sir. So, sir, just one thing. Those who are having high computing devices and huge amount of storage, so maybe they will not be required to, perform the computation in a distributed manner. And of course, there is additional cost when we are going to, perform the computations on cloud, because communication delay will also be there, sending the data and receiving the response from the various, units where training is being done. So basically, it will be useful for them who are having, less computing power or storage power. Is it correct, sir?
Yes. For example, one best example I am giving you, the best example is military applications. In a military application, suppose you want to process the data of a geographical location. So you don't have, in the battlefield, you don't have this high performance computing system. You want to process the data over the drones and you want to take a certain decision.
Yes, correct, sir.
Okay, so there are actually what you are telling, that is perfectly fine. That why we are going for federated learning. This is a completely bogus thing. But everything depends on applications. You cannot say that one thing is useless, one thing is useful. Okay, so I believe that you are able to understand my.
Yeah. Thank you, sir. Thank you very much.
So this is the federated learning. Now, federated learning is having its own challenges, and the challenges are. So I will go through it. So what you can understand right now from this particular title, that the problem of federated learning will be further addressed with the help of blockchain technology. And when you are associating blockchain technology with federated learning, then the devices will consume more energy and more latency will be required. And to address that particular problem, we have proposed certain algorithm over the edge networks, and we are coming up with a research paper. This is the title of one of my research papers that is published in IEEE Transactions on Circuits and Systems Brief. So basically, you can understand there are three technical terms involved over here. One is the concept of edge network. Then over top of it, we are having federated learning, and top of it, we are having blockchain technology. And when we are integrating these technologies, we are facing certain challenges in terms of energy and latency. And we are proposing in this particular work certain methodologies through which we are addressing the problem of energy and latency in the blockchain-enabled federated learning for the edge networks. Now the title is clear to you all.
Yes, sir.
Yes, sir.
Yeah. So now the next question I should ask you that what is the blockchain technology, but we are having very limited time and I have to cover so many things. Okay, so I cannot ask you every time that what is this, what is that. I'm not here to check many things, but yeah, I should, in the beginning, I'm asking many questions to you so that I can understand that at what level you are, in what depth I should go. So I came to know that what I have to do. Now we are proceeding with this particular title. Now, this is the motivation. I believe that my slide change is visible to you. Now I am on the motivation with federated learning. It is visible to you?
Yes.
Yeah. So motivation with federated learning. So you can see that I have written certain statements in form of bullets that as data-driven technology advantages, more data is generating, placing greater demands on centralized computing and increasing the concerns of data breaches. That is the first motivation. When you are having a whole data on a particular location, then the chances of data breaches are very high. And this federated learning is basically a distributed approach through which we can address this challenge of data breaches during machine learning process. Okay. Now, in contrast to centralized computing, which shares raw data, devices in federated learning train models locally and then communicate parameters to central servers that aggregates local models and compute the global model. That I have already told to you. And the updated global model is again shared with the edge devices for further updates in the next round. So this is the series of rounds, iterative process. And again and again and again and again, this process will be repeated till we will not be satisfied with the performance or the output performance of the model. So this is basically one round of federated learning. Means like you are doing the training on the local device. The train model parameters are going to be sent to the cloud server. Cloud server is doing this certain aggregation mechanism, applying certain aggregation mechanism, and again the aggregated model parameters will be transmitted to the local devices. This is the one round of federated learning. So other advantages are in terms of improved latency, improved scalability, improved performance in terms of energy, and complement the privacy preserving quality of federated learning by these 3 or 4 aspects you can understand. So this is the beauty of federated learning. Now, challenges with federated learning. That what are the challenges with federated learning? So still you can see that what I am basically doing, I am not supplying the whole data to a particular server, but still I am relying on a central server. Means if my central server is going to be attacked by someone, then my federated learning business is also gone. Because the convergence of or aggregation of the model parameters is going to take place over a centralized location. Do you agree with this statement?
Yes, sir.
Yeah. So the dependence of federated learning on single central device for accumulating and aggregating the local models make it vulnerable to single point failure. So this is the very primary challenge, very basic challenge with the federated learning. Additionally, the lack of participation incentives discourages edge devices from using the resources for processing data locally. So what is going to happen? If the devices are not well motivated that I should participate into federated learning or not, then the devices will not participate into the federated learning. So you have to incorporate certain incentive mechanism which will motivate the devices to participate into the federated learning. So several previous studies have addressed the no incentive drawback with incentive mechanism to motivate edge devices to contribute. So you can see that reference number 3 and 4, what I have written at the bottom, they have used certain incentive mechanism to motivate the edge devices to participate into the federated learning. Now, there are two primary challenges you are able to understand. That one is single central server, another one is incentive mechanism. So both the challenges can be addressed simultaneously by leveraging blockchain technology within federated learning framework. And you can see that reference number 5 and 6, they have introduced the concept of blockchain in the federated learning to address these two challenges. Is it clear to you? Is it clear? That
Yes, sir. Very much.
how I'm so now I have told you that if blockchain technology you are going to integrate, then everything is solved. So you can see that blockchain enabled federated learning comprises as devices and miners. So how this blockchain is going to help? So first we should understand that what are the steps involved in the blockchain. So in the blockchain, what is going to happen? Each edge device updates and uploads the local model parameters to its associated miner. Now you understand. I will show you one diagram where I have given the system model of the blockchain enabled federated learning. Right now you can understand that there will be a miner, and the miner will be selected from the devices itself. Suppose you are having 500 devices, so 10 or 15 miners will be selected who will be the responsible person to collect the devices of all the 500 devices. So each miner verifies the local model obtained from its devices and other miners. This initiates a federation of trustworthy devices, and after verifying local models, miner try to complete proof of work to generate block containing global model parameters. So after this, what is going to happen? Miners will try to complete the proof of work, and after completing this, it will generate a block to get added into the blockchain. Okay. And miner that finishes proof of work first and succeeds in propagating the generated block gets to add its block to the blockchain. Devices download the global model from the added block for the next federated learning round. So this is the concept of blockchain enabled federated learning. So the considered architecture of blockchain enabled federated learning framework is illustrated in this particular slide. I will just show you. So you can see that what is happening, this brown box, dotted brown box, you can say this is the concept of federated learning, and this one, bottom one, is the blockchain technology. And when you are going to integrate these two, then we are talking about blockchain enabled federated learning. Okay, so here itself we should understand that what I'm trying to tell you. You see that these
Hello.
are the set. Yeah.
Sir, I have one question that in a blockchain-enabled federated learning, there is no need of central server or crowd.
No.
Okay. Then all the communication happen and training of the model or converge parameters among the participated devices only.
Exactly.
Okay.
So what is happening? Like a group of devices, you can see. Are you able to see this particular diagram?
Sir. Yes, sir.
So you can see that a group of devices, actually it is wrongly written miner 2. This is miner 1, this is miner 2, this is miner 3. So this is miner 1, this is miner 2, this is miner 3. Now you can see a group of devices will be connected to the miner 1. A group of devices will be connected to miner 2. A group of devices will be connected to miner 3. And local training will be done on the devices. Now what is going to happen? This trained model parameters will be sent to the miner. They will send to miner 1, they will send to miner 2, they will send to miner 3, and then miners will do the cross verification. proof of work, the concept of proof of work will be started, and whoever will be the winning miner, that miner will add a block into the blockchain. You can say block propagation, and what is going to happen once the block is going to be added, this will be transferred to the devices again. This will be transferred to the devices again, and they will again do the training, and this process is iterated. So there is in this.
So sir, the miner is the different devices other than these edge devices.
Yes, but they will be from these devices only. Means, like for example, do you know this clustering process?
Yes, sir.
So in the clustering process, you will select a cluster head. In similar way, here the concept of miner is there. So
the miner is among the devices only that are participating in the training process.
Exactly.
And they are doing the additional job of the mining work also, other than the training of the model.
Exactly.
Okay. Thank you, sir.
So what is happening now? You can see that this diagram is clear to you all. Everybody is. I believe that I have tried my best to explain this particular diagram, and it is clear to you. Okay. Now we will go back to this. So you can see that these are the steps, and the same steps what I have shown you in that particular diagram, the same steps are written over here also. Okay. Yeah.
Sir, I have a doubt. I mean, like number of miners, will it depend on the number of distributed units?
Yes, number of like what you are going basically doing, you are making a group of devices, and that group of devices will be associated with a particular miner.
Okay. So maybe if there are 4 groups where computation is being done, then there will be 4 miners.
There will be 4 miners.
Okay, sir. Thank
you. So this is the basically the concept of blockchain technology. Now, it is not there like if you are going to integrate this blockchain technology, then it is always helpful. There are certain challenges will come. Now, what challenges will come? So if more than one miners generate a block at nearly same time, the block propagation delay leads miners to receive blocks from different miners. Now you can see in that particular diagram, there were 3 miners, 2 were in the brown color and 1 was in green color. The green color miner was the winning miner, and the brown color miners were the, you can say, loser miners. So suppose, unfortunately, there are 2 miners who are winning at the same time. Then whose block you will add into the blockchain? That is the primary question. And if you are not able to understand that who is the winner miner, then again you will iterate this process. Means the complete process, whatever you have been done, that will be again repeated. And this process is basically going to be called as forking events. Okay, so this causes disparities in miners' local ledger, giving rise to accidental forking. By repeating the entire blockchain process, this disparity can be resolved. But you can understand that if I'm going to repeat the entire process, I am going to pay in terms of latency, in terms of energy. Do you agree with me?
Yes, sir. Definitely.
Yeah. So what is going to happen? The model verification and storage of local models by several miners ensure the functioning of federated learning even when some miners fail. So that is the advantage of this federated learning. However, adding blockchain with federated learning process increases the network latency and energy consumption because of this accidental forking events. So additionally, the involvement of devices with limited processing power, bandwidth, storage, resources or insufficient redundant malicious data can slow down the learning process. So that is the primary challenge associated with blockchain technology. Now, what is the possible solution then? How I should what I should do so that I can run the process very smoothly and I should not waste my energy and latency. So you can see that selecting a subset of devices while acknowledging aforementioned factors can help to improve the performance with less resource consumption. So the important question is identifying that which set of devices are going to experience less number of forking events. That is the primary question. If you are able to identify them, then you will say that I will choose these set of devices as a minors, and they will help you to reduce the forking events, and the reduction in number of forking events will lead to a reduction in energy consumption and latency. Are you able to understand? I have told in a very fast mode, but I hope that you are able to relate. If you are not able to relate, I will repeat this because this is very crucial. Are you able? If not, I will repeat again. Say yes or no, please.
Yes, it is fine, sir.
So, device selection methods accounting for the resource consumption of the framework without compromising performance have been presented in 8. So, this research paper published in 8, this is not my research paper. This is published by someone else in 2020. And they have proposed a methodology in which they are selecting optimal set of devices, and with the help of that, they are not compromising with the performance of the system. Okay. A secure server-independent random device selection method is proposed in 8, which adopts a deep reinforcement learning-based algorithm to select as devices with high communication and computing resources. Okay, so this is the paper number 8. Now, they have proposed a deep reinforcement learning algorithm to select the as devices who will act as the minor when you are talking about blockchain-enabled federated learning network. Now, device selection using a reputation. This is another research paper. That is 3.
Sir, I have a doubt in my mind. How deep reinforcement learning will get the idea about which device is going to be appropriate?
Yes.
With respect to reference number 8. With respect to reference number 8. It is written that deep reinforcement learning based algorithm to select edge devices. So how it will be able to get the idea? I mean, this device is having high resources and all.
Yes. So basically, what you are going to do, you see that in the next points I have written device selection using a reputation. Reputation means you can say that like in this society, everybody is having its own reputation, right?
Yes.
You understand?
Maybe sir, this reinforcement learning is fine. That is, it is based on profit and loss. If some task is given to particular device and if it is able to perform it, then its reputation will be high and it will be given more tasks.
Exactly.
Now, what is the sense of deep here? I mean, why deep reinforcement learning?
Deep. Are you aware about this machine learning or not?
Yeah, sir. I am aware, little bit aware, not very much.
So deep means what you are going to do when deep means what? Deep means what do you understand by deep?
Actually, deep learning, maybe they have taken this deep word from there. Suppose that we have huge amount of data and we are willing to find out all the hidden information in the data. So classical models are not appropriate. So maybe deep learning models are going to be appropriate.
Yes. So when you are going to do the process in an exhaustive manner, like in the context of deep neural network, you are going to increase the number of layers. You are going to increase the data size of data set. Means you are going to do the analysis in exhaustive manners rather than on the limited manner. So deep reinforcement learning is telling you that whatever the reinforcement learning business is going to take place, that is accounting a large number of possible actions.
Yes, sir. Yes, sir. That I know. Anyway, it is their paper, sir. They know, what they have done. I mean, why, how they are collecting the large amount of data. This is the part of paper number 8. But of course, it is nice concept. Why, how they are selecting the devices. Yeah, fine, sir. Thank you, sir. Please.
So basically, you can just understand that they have developed certain reputation corresponding to individual devices, and on the basis of that one, they are going to select that which device I should select and how many devices I should select, which will act as the minus, so that I can avoid the forking events and I can address the problem of energy efficiency and latency within the network. Okay, so that is their research problem. So the studies in 10, 11, 12, you can see at the bottom I have written 10, 11, 12, and what basically they're published at good venues. So the studies in 10, 11, and 12 use local resources for performance as comparison matrices and did not consider the increased resources brought by the introduction of blockchain in federated learning. So they are able to address this with the help of blockchain technology. They are bringing this, they are making their system distributed and everything they are doing, but they are not considering the challenges associated with blockchain technology. They are not focused on that. So to this end, we aim to optimize this single round latency and energy consumption jointly while selecting an optimal edge device set. The proposed method is evaluated on publicly available speech dataset. Not only on this speech dataset, we have also evaluated the performance on image dataset also. But because we have published our research paper in transaction circuits and systems brief that is limited to 5 pages, we were not able to present the work, the result obtained on the image dataset. We have removed that particular complete analysis from the research paper, but you will understand by seeing this speech dataset available in the reference number 13, and you can see that with the help of this speech dataset, we have analyzed that our proposed method is doing extremely well in comparison to other existing methods. Okay. So what is the summary of the proposed method? So you can see that the introduction of blockchain in federated learning can initiate a federation of trustworthy devices by validating the local model. That is fine. However, the challenges arise due to the blockchain framework in increased latency and energy consumption. That is also correct. You are able to understand that why it is happening so. And therefore, there is a need to develop or propose a blockchain-enabled federated learning framework that jointly optimizes latency and energy consumption. That we have done by proposing some of the algorithm. And the proposed model can consider any data set. As I have told you that we have also validated our performance on image dataset apart from the speech dataset, suggesting that an optimal set of miners helps reduce forking events, latency and energy consumption. So that is by default, if you are able to reduce the number of forking events, obviously you are going to reduce the latency and energy consumption, and the performance needs to be compared with existing method in the literature. And we have compared the performance of our proposed method with the existing method, and we have got very good results. So this is at the bottom, you can say this is our research paper, which we have published in 2023. This is the system model that I have already explained to you, that what kind of system model we have taken. So this is the system model we have taken into the consideration. And there are certain mathematical notations written over here that, for example, you can see that NM is the number of miners. Italic NM is the set of number of miners. ND, you can see like so many symbols I have written over here. If I will read, then it will unnecessarily take time. I have to cover many things. You can, from this particular slide, you can understand that which symbol is going to represent what thing. Okay. So ND, you can see that the S devices, NM is the number of miners, and so many variables. So this whole system model, I believe that it is clear to you, right? Now, what are the proposed steps? So the proposed steps are saying to you that you will do local model update, local model upload, local model verification, block generation, block propagation, and global model download. That is the, you can say, that is the entire process. So what is the meaning of local model update? Each selected device downloads the latest global model parameters from its associated miners. What is the local model upload? After updating the model parameters, the selected device share the model updates to their associated miner. So local model verification means they are doing cross verification. Then after cross verification, they are going to do the block generation. Once the block generation is done, then they will do the block propagation. And when the block propagation is done, then the global model will be downloaded for the next round of the federated learning. So this is the entire steps when you are talking about blockchain enabled federated learning. Is it clear to you? If it is not clear, you please ask me. If somewhere you are confused.
Yes, sir, it is okay.
Yeah, thank you. Now, what is the problem formulation? So I think the particular slide is little bit horrible for you, but it is very simple. You can see that there are two equations, two primary equations. One is with respect to latency and other one is with respect to energy. Now, a fork is the number of forking events, that how many forking events are going to take place. And that this number of forking events are going to multiply with time required in the computation, in the upload, in the verification, in the block generation, in the block propagation, and then download, model download. So model download is not associated with forking events, only the computation, upload, verification, block generation, and block upload are associated with forking events, and then you will add this download, time taken into the download. So this all times instances will be added, and that will generate the complete latency. That will give you the matrix of the complete latency. Similarly, the energy consumed in the computation, upload, verification, block generation, block propagation, that is the one round of the federated learning in the blockchain enabled network, and then energy required to download. And when you are going to multiply this a fork with this particular, so you can understand that if number of a fork is going to represent the number of forking events. If number of forking events are going to increase into the system, then your latency will increase or decrease.
Of course, it will increase.
Of course, it will increase. Actually, if you will ask class 2 student, he will answer. But what I just want to let you understand, the physical significance. The physical significance is more important. Means you can make an image in your mind and you can understand that there are so many miners in the system, and as the accidental forking is going to increase into the system again and again, you are repeating the entire process of the block generation, and that is leading to more latency and more energy consumption of the system. Okay, mathematically, if you will say, then even class 5 student, class 4th student will tell you that if you are going to multiply x and y and you are going to reduce the value of x, then definitely the value, the product will be also reduced. So that is mathematical, but you should understand the physical significance, that what is the meaning of this, what is the physical significance of this. So you can understand that where a fork denotes the number of forking event, and it is equal to 1 by 1 minus p fork, where, so this reference 9, this this particular P fork, the expression of P fork I have directly taken from this particular research paper, which is mentioned in reference 9. So this is the P fork. Now the question is, this P fork is, you can understand like exponentially distributed random variable, and exponentially distributed random variable is associated by 1 minus P fork, and that is going to represent A fork. So mathematically, if you want to understand that how the forking events, how the probability of forking is going to increase, then how it is going to affect to the energy and latency, that is given in this particular equation. But exactly if you want to understand that what is the mathematical expression of A fork and how it is going to be associated, then you can understand this particular complete equation. Okay, is it clear to you? Is it clear to you?
Yes, sir. Yes, sir.
Now, what I have told you that we are jointly addressing the problem of energy and latency. Now you can see that on individual parameters we can work on individual parameters like energy and latency. But if you want to work jointly, then what you have to do, you have to make a cost function, and the cost function is denoted by beta T is cap and 1 minus beta E cap. So optimizing only energy may increase the latency of the framework, slowing down the convergence. And if you are making more faster the system, then the energy will be affected. So what we have to do, we are making a particular objective function, and the objective function is basically the summation of both the terms, energy and latency. Now you can see that we cannot add kilometer into liter. So what we have to do, we have to normalize these two parameters. And for normalization, what basically we are doing, we are using this particular formula where T cap is the unitless and E cap is also unitless. So by making them unitless, we are able to add them, and we are assigning certain weight parameters, beta and 1 minus beta, and accordingly, like if you want to reduce more latency, then you will increase the value of beta or decrease the value of beta, and you are able to develop a cost function. Now the goal is to minimize the cost function. If you are trying to minimize this function, if you want to minimize the latency and energy consumption, then you will try to minimize this particular function. Now, subject to this particular function will be minimized subject to cardinality of SM is greater than or equal to 2. Now it is my question to you that why I have taken cardinality greater than or equal to 2? Why I have not taken cardinality greater than or equal to 1? Or I have not taken cardinality greater than or equal to 3 or 4 or 5? Can somebody tell me? If somebody will tell me, I will be very happy. Can somebody think?
Sir, when we are going to have equal to 1, then I think the kind of negotiation is being done. It is it will not work. So at least
Why it will? Why it will?
Yeah.
Why it will not work?
Maybe the required kind of negotiation cannot be done because only one.
No. Now I will tell you the answer. If you are making SM greater than equal to 1, then you are making the system centralized rather than distributed. Means this is minor. If you in the system you are using a single minor, then the system is no more distributed. It is centralized system.
So, yes, sir. Actually, this is the case. Yeah.
Okay, so that is the reason. And if you are keeping greater than or equal to 2, then always it will be a distributed system. Only as the number of miners you will increase, the more number of S servers you are bringing into the system. Okay.
Yes, sir.
Yeah. So this is the joint optimization problem, which we have formulated, and I believe that everything is very neatly explained to you. Now, what is going to happen? Algorithm for optimal device selection. How we are developing algorithm for optimal device selection? So you can just understand that we are minimizing the number of forking events, and that is with the help of that at which device the possibility of the forking is low. So the device which are generating less number of forking event, with the help of some of the model training, we are able to understand that those devices we are selecting as the miners, and we are proceeding to minimize the number of forking events. So this is the complete algorithm. I just want to request you to understand this complete algorithm for optimal device selection. This is the heart of our work. So you can just understand, you can go through this particular paper where we have explained each and every step nicely. You explore this, you will come to know that how exactly we are doing that. So this is the algorithm for optimal device selection for our method, and this is the block diagram for optimal device selection. So you can see that we are having all devices, and we are selecting the miner, then we are doing model download, local training, model upload, and then we are doing cross verification, proof of generation, then we are doing miners, block propagation. Then if the devices are doing this forking, if yes, then we will not generate the block. We will again do the model download, local training, and model upload. But if it is not generating, then we will do the block addition, and we will again start from the beginning. So this is the complete block diagram for the optimal device selection. That is the same way what I have in the form of algorithm I have explained here. So this is the flow diagram of the device selection in blockchain enabled federated learning, and this is the performance analysis. What the performance analysis we have analyzed. So the proposed method is analyzed over GKWS dataset, that research paper I have already referred to you, that consists of speech signal from 8 keywords. This is the data, you can say, which has been used by this particular dataset. The dataset comprises 2,000 samples from each class that is non-uniformly distributed across S devices. A convolutional neural network model is employed for classification using TensorFlow federated learning framework. The spectrogram of each signals is used as the input feature. The feature extraction part of the CNN model consists of one ReLU activated layer and 64 filters, followed by ground normalization and max pooling. Then the classification part of the CNN model consists of flattening layer, ReLU activated fully connected layer, and group normalization layer and dropout layer, followed by softmax activated output layers with 8 neurons. Okay, so this is the basically you can say the characteristics of the used model and the data set, and what results we have got. So what results we have got, you can see that this is the latency, this is the energy consumption, this is the accuracy, this is the F1 score, this is the number of miners, and this is the number of forking events. So you can see that as the number of miners are increasing, or the number of miners are decreasing, accordingly the latency and energy consumption are increasing or decreasing. So, but you can see that that as the number of miners are 25, this is the latency corresponding to 25, this is corresponding to 20, and this is corresponding to 15. So as the number of miners are reducing, you are able to get the low latency, because the processing number of forking events will automatically reduce. So in similar way, if latency is reducing, the energy consumption will also reduce. In case of accuracy and F1 score, you can see that in case of this, if the number of minors are more, then you are getting less accuracy, because then the chances of classification, better classification, will go down. And same thing is going to be applicable for F1 score also. And similarly, the analysis on the number of forking events, and you can see that as the number of minors are going to increase, the number of forking events are going to increase. So this is the performance analysis what we have got with our approach. But for comparison purpose, like this is going to just show the results corresponding to our method. To understand the results, the comparison with other existing methods, we have taken this random approach. We have taken this paper number 16, paper number 8, paper number 12, paper number 15, and we have compared the performance of our proposed method. You can see that latency and energy and accuracy and F1 score with other existing method, if I'm going to compare, then the proposed method latency is quite low in comparison to other existing methods. Energy consumption is also quite low in comparison to other existing method. But you can see that the accuracy and F1 score, in some cases, our proposed method is not giving better in comparison to the existing method. Some of the existing method we are beating, but when we are comparing with some other existing method, we are getting poor results. So this is the performance analysis corresponding to the proposed method when comparing to the existing method. Now, this is another research work what we have done, and this work is published in IEEE Transactions on Sustainable Computing in the year 2024, this year only. And you can see that we have already understood. So this what previously we have seen, that is completely different work, and this one is completely different work. You can see that centralized learning models face several challenges, such as that we have already understood. That's what there are certain challenges associated with centralized learning models. Now, blockchain-enabled federated learning which will deal with trained model parameters only rather than raw data, that we have already understood. So, blockchain-enabled federated learning suffer with the challenges of exponential increased access space in deciding various parameters levels.
Sorry, am I audible?
Yeah.
Sir, so that you are beating host, you can mute, this a particular applicant. Actually, background noise is there.
Who?
And Koiba, some name is there.
Koiba.
Yeah, you can see. You can see here in the third number.
Yes, this one.
Yeah, you can mute this.
Yeah, Thoiba, are you there? Yes, Thoiba.
Sir, you will have the right to mute him. Please take it once. 3 dots. Yeah, please.
Yeah.
Thank you, sir. Thank you very much.
So this is completely new work, and what is happening in this work, in similar to like in the previous work, what we have done, we have selected optimal devices for the optimal device selection we have done. In this work, we have optimized that devices will work at what level of parameters such as energy, and at what level of data the devices will work, so that we can improve the performance of the network. So you can, the key point is, we are proposing in this work, we are proposing an actor critic reinforcement learning method to model the machine learning model owner in selecting the optimal set of parameter levels, addressing the challenges of exponential growth of action space in blockchain-enabled federated learning network. Now, it might be that you are not able to understand what he is telling. So the thing is, like a particular device will always work at a particular energy level and with a particular data level. So we are in this particular work, we are with the help of proximal policy optimization method, we are applying and we are identifying that at what should be the energy level over which a device should work and what should be the data level over which the device should work. This work we have done, and actor critic method, reinforcement learning method balances the exploitation trade-off and shows the better performance than most of policy methods on large discrete action spaces. Considering the mobile scenario of the devices, MLMO decides the data and energy level that mobile device use for the training and determine the block generation rate. So this is the completely different work in comparison to the previous work. So actually I have very limited time because like I have to cover some part of the supervised learning or IS assisted IoT network. I have to give a break also to you. So quickly, I just want to finish this particular presentation. So you can see that this leads to that we will understand that this method is going to help us to achieve this targeted accuracy with reduced overall cost and all. You just understand that what is the system model, proposed model. So you can see that this is the block is going to be generated with the help of proof of work concept and all, and again it is going to be sent back to a particular MLMO, and that is going to be work as a miner. So this is single scenario has been shown to you. So this is the proposed system model. These are the obtained results. You can see that we are increasing the number of episodes, and this graph is nothing but this blue box, whatever the portion is there, we have enlarged and we have created a separate graph over here so that we can understand that the PPO method, our proposed method, you can understand in better way that it is giving far better performance in comparison to other two approaches, that is greedy and deep queue network. So you can see that the proposed method cumulative reward, the cumulative reward in case of the proposed method is very good in comparison to deep queue network and greedy approach. So in this one, greedy is not there because it is going to lie very far away from these two, from the performance of deep queue network. So this is the performance of the cumulative reward. And the same analysis has been, whatever the analysis you are able to see in this particular graph, the same thing in the form of word is written over here. In the form of word is written over here. Again, you can see that invalid action counts in case of the proposed method, which is the proposed method is PPO, GE and PPO Monte Carlo. You can see that the invalid action counts are very low in comparison to deep queue network and greedy approach. So again, in this graph is nothing but enlarged version of the blue portion. In the blue portion, whatever the part is coming, we have enlarged it and we have again plotted it. So that is the you can see invalid action count with the number of episodes. So as the number of episodes are increasing, in all the cases, the number of invalid action counts are reducing. This is the performance analysis with convergence steps, that how many steps are required for the convergence. So you can see that proposed PPO JE and PPO Monte Carlo is having very less number of steps required to get the convergence. And this is the latency. You can see this is the latency in seconds with the varying number of episodes. So you can see that as the number of episodes are increasing, the latency in case of the proposed method is quite low in comparison to other approaches. Okay. And this is the energy consumption. You can see that energy and cost. So basically this is the variation of energy with the episode, and this is the variation of the cost with the episode. So in terms of energy also, we are getting very good performance in case of PPO approaches, proximal policy optimization frameworks. And cost wise also, you can see that our proposed method is giving better performance in comparison to other approaches. So now your question will be that what is the cost? So cost, we have made a particular function which is telling us that these parameters are involved to make the cost function, and if you are able to reduce the cost function, definitely we are able to improve the performance of the network. Now, this is the training time. So as the number of devices are increasing, you can see that we have done the analysis with 2, 3, 4, and 5 devices. So the training time required in case of TPO methods, you can see it is very low in comparison to deep queue network. So here we have not compared with the greedy approach, we have just compared with the deep queue network, and we are able to see that the performance is quite good, very, very good in comparison to the deep queue network framework. So this is the presentation on energy efficient and latency aware blockchain enabled federated learning. Now, if you are having any questions, yeah.
Sir, I have some questions which was, slides where you presented the line graph. With respect to forking and number of fork and number of miners. The graph.
You just tell me that at which slide?
Just this one, sir. Performance analysis. As
yes.
you have mentioned. So, sir, I can see some limitations of the work. Can you tell us what are the limitations of this work?
Limitations of this work, you can understand right now. Like, there are so many aspects. In which aspect you are asking? If you will highlight, then I will tell you.
Like, sir, if you look at the testing accuracy and F1 score, so while explaining, as you have mentioned, that when we increase the number of miners, then accuracy and F1 score is going down, as you explained. So maybe if we are looking for higher accuracy, maybe let's with respect to machine learning model. So this distributed system is having some kind of limitation. I mean, sending the multiple samples to different units and let's say collecting the learning information from there and then performing the task is a kind of limitation. It will not be highly accurate and its F1 score will be low.
Of course, very true, very true.
And another thing, sir, as number of forking events, it is user input or some kind of distribution is there. It is generated with the help of some models.
Yeah, so actually number of forking events you can because right now you are working with the simulated environment. So the number of forking events you have to generate by your own to understand that you are able to detect the correct optimal device or not. You are able to understand that. Now, for example, in the simulation, you have to use some of the distribution functions and you will apply that particular distribution function on all the miners. And your algorithm should identify that which particular miner is generating higher number of forking events. That is the goal.
So, sir, in this work, you have used, user inputs for forking, right?
Exactly.
And sir, one more thing, this GKWS dataset, is it a kind of image dataset?
No, it is a speech dataset. We have a CIFAR dataset. We have also done the analysis, but that is not presented in this particular work because if we are going to present, then the number of pages were getting exceeded and journal was not allowing us. So we have removed completely the image dataset. We have only worked with a speech dataset.
So is it kind of classification? I mean, class labels were there or not?
Yeah, you can see that here: go, stop, left, right, up, down, yes and no. These are the classes, you can say.
Okay, sir. And just one more thing, sir. Can you tell us about the platform? How you have simulated? This particular algorithm to test the model and all. because machine learning is there, blockchain is there, and cloud computing concept is there. So which platform you have used so that we can also try?
Yeah, so in Python, there is a TensorFlow. Even you can say PyTorch is there. So many libraries are there basically in TensorFlow. So we have worked in this Python coding.
So in Python, machine learning part is okay. I mean, TensorFlow library, it supports the various models, directly we can import from there. How you managed the cloud computing part and blockchain part?
Okay, so cloud computing parts means like you can say that when you are providing all the data if machine learning part is okay in the Python, so you can understand that you will deploy a particular model, you will supply the data and it will do the classification. So that is the cloud computing business. Now in the edge computing, only you have to break the data and you have to yes.
Sir, please repeat the last section. The network issue was there. So how you are implementing the cloud computing section there?
Cloud computing section, like you simply understand in this way that how you are going to, if somebody is asking you that you please implement CNN model, how you will implement in Python. So you will develop a CNN model in the TensorFlow and you will give the stride value, you will give other padding value, and on a particular model you are training the data. So that is the cloud. Whatever you are doing, that is the cloud. Whatever the classification accuracy, precision value, recall values you are getting, that is corresponding to the cloud. And when you are breaking it in this data small packages and you are training on different same CNN model, and you will not get that much accuracy. You will not get that much accuracy what you are getting corresponding to the whole data set when you are supplying. So with the help of those trained model parameters, again you are supplying to the you can say on a particular location, on a particular CNN model, and you will try to get the converged model with the help of some fed SGD or fed average model. Aggregation model. And
what about blockchain part, sir?
So the blockchain part, when you were talking about cloud, so many miners, so like you can say that when you are breaking the part, when you are splitting the data on different S servers, so those S servers, how they are communicating to each other to generate the block. That is the way.
I am looking for how we can implement this blockchain part along with the machine learning, using Python. So machine learning part is okay for me. I have published a few papers in good journals, and I have worked on blockchain also, but separately, Python platform I have not used. And your paper is a combo of machine learning and blockchain, so it is quite seems fancy for me, and I look for it. So that's why I'm asking that how machine learning and blockchain can be clubbed together using this particular platform.
Okay, so if you are able to understand that the concept of blockchain or not, first you tell me.
Yes, sir. I have just.
So what you have to just do, like simply, if you are able to understand, I believe that you are able to understand the difference between cloud computing and the federated learning. That is also clear to you.
Yeah.
If that is clear to you, so what you have to do in this federated learning, in the cloud server, whatever a single cloud server was there, now multiple several, you can say, you have to create several S servers, and those S servers will perform the task of proof of work concept, and accordingly they will generate the block, whoever will be the miner. So exactly how I have implemented that is right now it is difficult to show you through the coding, because I'm not prepared with those things. But whatever the concepts I have told you, you have to just simply implement slowly by yourself, and you will get those things.
Okay, sir. Please share your paper, sir, so that we can read it.
I will. Right now, I am not prepared with this demonstration. Otherwise, I can show you that how exactly the data is going, how your model, because that is also very time-taking process. Okay.
Yeah, sir. Of course, sir.
So I cannot show you.
So around 6 months to a year work cannot be presented in our hour. It takes time to prepare the paper, and explaining in 1 hour is very difficult.
No, this work, what I have presented, it took almost 3 years.
3 years. Okay, sir. Very nice work.
Okay. So it is not very easy. So no problem. At least you got something, some idea you got.
Definitely, sir. Very nice work.
So Dr. Sunil Kumar, you are from which place?
I'm working in Mahatma Gandhi Central University, Motihari, Bihar.
It's Motihari, Bihar. Okay.
Department of Computer Science.
Okay.
I did my PhD from Jawaharlal Nehru University, New Delhi, JNU.
Okay, JNU.
I'm familiar with the A.K. Tripathi, sir, and my guide is a student of Professor A.K. Tripathi. Professor Dev Prakash Vidyarthi, sir, is my guide. He is professor at JNU.
Okay. Very nice.
Thank you, sir. Thank you very much.
Yeah. So we will take a break, and then we will meet at I think the time is 5:40 almost. So we will again meet at 6 o'clock. But I don't know that I will be able to cover a third topic or not, because the second topic also will take some time. This RIS assisted IoT network using machine learning framework. So then we will start that. We will see that how much other portions we are able to cover. Okay.
Sir, please share your.
There is some form of hello.
Hello.
There is some form of implementation could be shown. It will be better. How you are implementing, because algorithmic presentation is okay, but how you are actually implementing. If that can be shown, then it will be better. I think.
Yeah. Next,
I go to that platform.
Yeah, I will. What I will do, I will prepare a demonstration presentation so that you can understand.
Yes.
But not this time. Next time when I will get an opportunity. Okay.
Okay. Thank you.
So we will again meet at 6 o'clock. Okay.
Yes, sir. Thank you.
Please join at 6 o'clock again. Okay.
Hello everyone. Anybody is there in the... Hello?
Yes, ma'am.
Hello? Ma'am, can you please join the WhatsApp group? I have shared the link so that it will be easier for all of us, because only through the mail that is coming. All of you, I request all of you to please join the group, WhatsApp group. Paramjit sir, you're there?
Ma'am, where is the WhatsApp group link?
Yes, where is the WhatsApp group? There is no WhatsApp group.
Ma'am, again I have shared it in the chat box. Kindly just check it. Did you got it? Thank you all
Yes,
of you
we
for
got it. Yes.
joining the group.
Yes, ma'am,
This
done.
is the informal group. This is okay. Thank you so much. This is an informal group now. Nothing is official here, so we all can communicate with each other for the other work. Whatever the discussions are there.
So should we start or can we start or should we wait for a couple of minutes? Are you able to listen me?
Yes, sir.
Yes, sir. Yes, sir.
So can we start?
Sure.
Yes, sir.
So are you able to see my screen?
Yes, sir. It is visible.
Okay. So, so this is basically a new topic that is reconfigurable intelligent surface assisted IoT network using machine learning frameworks. So how many of you are aware about this reconfigurable intelligent surfaces? And anyone who is aware about this? Are you aware? Anyone who is aware? Otherwise, I will have to go and tell you from the basics. Please answer yes or no. Are you able to listen to me?
Yes, sir. We can listen.
So I'm asking that are you aware about this RIS or not? Reconfigurable intelligent surfaces. Have you heard about?
No, sir.
No. Just a moment. So basically, RIS assisted IoT networks. In this presentation, what we are going to do, we are going to see this. First, we will try to understand that what is this RIS, reconfigurable intelligent surface for IoT. Then we will understand this. What are the primary difference between passive and active RIS system? Because if you will see RIS system, then it is going to be into two categories: passive and active RIS system. We will understand a particular research paper where some of the research analysis has been done with respect to active and passive RIS systems. So they have provided a particular network model considering RIS assisted IoT system, and they have done certain analysis. That analysis I will present in front of you. Then we will understand the importance of RIS assisted IoT networks. We will subsequently understand this multiple active RIS assisted IoT network, and we will primarily discuss our two research papers. One is low latency data transfer using active RIS elements. Another one is optimal reflective elements grouping model. And we will see the conclusion and future work thereafter. So first, if you want to understand, so how many of you are belonging from wireless communications? Have you anyone who have ever worked on wireless technologies? Anyone? Please say yes or no.
Yes, sir. During my PhD, I did a few publications in this area, but right now I'm not very much comfortable because working in machine learning and all. So,
okay.
Yes. Sir.
Okay. Fine. So basically, first we will try to understand that what is basically wireless communication, because other people will not be able to understand when if I will directly jump into the RIS. So wireless communication is basically when we are transferring some information between two devices using wireless medium. So that is wireless communication. So primary two challenges will arise when we will transfer the data from one device to another device. The one challenge is fading, and fading phenomena. Fading phenomena occurs due to reflection, diffraction, refraction, scattering phenomena in the wireless medium due to various obstacles present in the environment. For example, building, trees, industries, and other devices and other entities. So that is fading phenomena. And if you want to understand the exact definition of the fading, then you can understand that the fading is the deviation of that animation that a signal experience in a certain propagation medium. Okay. So, and the second phenomena which create problem for the signal, that is noise. And noise is basically primarily that is going to be modeled as additive wide Gaussian noise. And if you will see the modeling, then it is modeled as a Gaussian distribution function. And Gaussian distribution function is basically f of x will be equals to 1 by square root of 2 pi sigma square exponential of minus x minus mu whole square by 2 sigma square, where mu is the mean and sigma square is the variance. So this is the noise, and fading is basically modeled as Rayleigh fading, Raishin fading, Nakagami fading. And suppose you are transmitting a symbol x from one device to another device, then you are transmitting x, then the received signal will be represented by y, and y will be written as y is equal to hx plus n, where x is the transmitted signal, h is the fading coefficient, and n is the noise. Are you able to understand this particular mathematical expression? Y is equal to the received signal y will be equals to hx plus n, where x is the transmitted symbol, h is the fading, and n is the noise. Okay, this is the mathematical expression. If you have not heard this expression, you please note it down, because this is the primary mathematical equation for wireless communication. Okay. Now, if you are able to understand, if you are able to get this particular mathematical expression, then what is the goal? The goal is, suppose just a it is important call. So basically, this is the wireless communication, and if you want to understand that how this reconfigurable intelligent surface is going to play a role in the context of wireless communication, then you can understand that RIS are regarded as one of the most promising techniques for enhancing the spectrum and energy efficiency of wireless systems. They are capable of reconfiguring the wireless propagation environment by carefully tuning the phase shift of the large number of low-cost passive active reflective elements. So what is happening when this is the, you can say, access point, you can say that this is the base station, for example, and you are a mobile user. Suppose you are a mobile user, then from the base station directly the signal will come to you. And sometimes what happens, due to obstruction, this AP and user link will be broken. Means, like, suppose in front of you there is a building, then this access point will not be able to transmit you the signal. Then what will happen? Usually a RIS, reconfigurable intelligent surface, will be placed, and the access point will transfer the signal to RIS, and RIS will reflect that signal to the user. Now, if you are able to understand that when the signal is coming to the RIS, and the RIS panel need to adjust the signal in such a way so that when it will reflect the signal, the user will get maximum information. So these are the phase shifter or reflective elements, they are going to be called as. These small squares, they are basically phase shifters. So these phase shifters are meta materials, and they will adjust their phase in such a way that the reflection will be more constructive towards the user. So the optimal reflection coefficient of the rays are calculated at the base station and then sent to the rays controller through the dedicated feedback link. The design of the reflection coefficient depends on the channel state information. So you can see that what exactly is happening. Exactly, this access point is transferring the signal to RIS. This AP and user link is blocked, and you have to do certain mechanism. And I have primarily used machine learning for this purpose, so that they will do the beam forming in such a way that user will get maximum information transmitted by the access point. And this phase shift will be controlled by the RIS controller, by the help of the RIS controller, and they will adjust their phase accordingly. So far, you are able to understand that what is the meaning of wireless communication and how RIS is going to help to improve the performance of a wireless communication system. Are you able to understand or not? Anybody, please, if you are understanding, then yes, say yes. Otherwise,
yes, sir.
You are able to understand, right? Okay. So now, this individual phase shifter, whatever has been highlighted over here, you can see that what is the meaning of this. So you can see that what is happening, you are a user, and this is the base station. Base station is transmitting the signal to the RIS. RIS is reflecting back signal to the user. Now, individual reflective element is illustrated over here. You can see it is a combination of capacitor and inductor and resistor. And with the help of that, we are able to develop a circuit which is helping us to get maximum signal to the user. Are you able to understand this part?
Yes, sir.
Yeah. So this is the schematic diagram of a passive RIS circuit. Now, what are the applications of RIS? So in this presentation, what I'm just trying to let you understand, that adjusting the phase over this RIS panel of the reflective element is a crucial problem. And we have proposed two machine learning models through which we are able to adjust the phase of the RIS elements in such a way that we are improving the performance of the system. So that is the goal. So this presentation is all about RIS, assisted IoT network using machine learning frameworks. Now, what are the applications why basically RIS is important, why we are looking for this phase adjustment of RIS using machine learning. So you can see that this is going to help us. RIS added cell edge systems are going to be developed. RIS added millimeter wave system. RIS added indoor Wi-Fi systems. RIS added unmanned aerial vehicle sensor system. RIS added simultaneous wireless information power transfer system. RIS added physical air secure system. So all those places in the context of wireless communication, we are in current scenario, we are using RIS. And in over the RIS, adjusting the phase of reflective elements is a crucial problem, and for that we have used machine learning frameworks. Okay, so with a meta surface equipped with integrated electronic circuits, RIS has the power to combat adversarial effects of wireless propagation and will substitute the traditional structure of wireless network to an innovative hybrid one with both active and passive components. Each element on the RIS is capable of reconfiguring the wireless environment between the base station and user constructively or destructively by imposing an independent phase shift to the incident signal. That is the concept of RIS. Now, coming to the understanding, after understanding this RIS is also divided into two categories. One is passive RIS system and another one is active RIS system. We will understand in more detail about passive and active RIS system in the next slide by a diagram. But right now you can understand certain key points that passive nature of RIS assisted IoT networks suffer from the multiplicative loss in the reflected path between access point and IOD. So what is happening? That passive nature, due to passive nature of reconfigurable intelligent surface, because what are the passive elements and what are the active elements? Can somebody tell me? Electric components, if I'm talking about, then what is the meaning of passive and active components? If somebody can tell me, then it is very nice to me.
The elements which are directly associated are active elements.
Can you repeat, please?
The elements which are directly associated for the machine learning or any such of activities are active elements, which are used during actual implementation.
No, actually, the active elements are those who can generate, who can amplify the signal. Means they are also supplied with the power. Means they can boost the energy level of the signal. So they are the active, and the passive is simply they will not generate the power. They will simply reflect the signal. That is the passive nature. So with the diagram, you will understand that what is passive, what is active in the next slide. But right now, you can understand that this multiplicative loss will be very much, you can say, a primary concern for the passive nature of RIS assisted IoT network. And RIS with active reflective elements improve the network performance by generating additional power amplification by incorporating the amplification phenomena. Active RIS can amplify and reflect the incident signal toward the receiving and elevating the multiplicative path loss between access point and IOD. So active RIS can amplify, but passive RIS systems cannot amplify and reflect the incident signal toward the receiving and elevating the multiplicative path loss in access point and Internet of Things devices. So a multi-RIS assisted IoT network where multiple antenna equipped AP serves the distant single antenna IODs via orthogonal beams. So in case of this, if we are talking about multi-RIS assisted IoT network, then definitely we have to go for the active RIS system, because if you will talk about passive RIS system, then it will always do the task of reflection. And if you will take multiple reflections, then the signal will be so weak that it will not be having any meaning when it will reach to the destination. So we are talking about multi-RIS assisted IoT network with the help of active RIS systems. So these beams are amplified and reflected through multiple reconfigurable intelligent surfaces, and fewer reflective elements are required to improve the SNR of the network in case of active RIS systems. So that is the advantage of active RIS systems. Now coming to this illustration of passive and active RIA system. Now this diagram is demonstrating a clear difference between passive and active RIA system. So you can see that this part A and part B. Part A is indicating a passive RIA system while part B is indicating an active RIA system. So you can see that in case of passive RIA system, what is happening, that a transmitter is there which is transmitting towards the passive RIA system, and because this passive RIA system does not have the capability of amplification, the reflected beam strength is very weak, you can say, and the receiver is not able to receive good strength of the signal. However, in case of the active RIA system, you can see that the transmitter is again transmitting the signal towards the RIS surface, and this RIS surface is able to additionally amplify the signal, and you can see that the strength of the reflected signal is very strong in case of the active RIS system. So in case of passive RIS system, you are only having this passive components, but in case of active, you are having an amplifier in addition to the phase shift circuit. You are having an op-amp, operational amplifier, which is helping you to amplify the signal, and that is the reason that the reflected signal strength is very strong in case of the active RIS system. Okay, so this is the primary difference between active and passive RIS system. Now, in the form of text, it is written that a passive RIS comprises a large number of passive elements, each being able to reflect the incident signal with a controllable phase shift. Each passive RIS element consists of a reflective patch terminated with an impedance adjustable circuit for phase shifting. Additionally, integrated active reflection type amplifier, which can be realized by different existing active components such as current inverting converters, asymmetric current mirrors, or some integrated circuits. So this is the concept of passive and active RIS systems. So are you able to understand the difference between passive and active RIS system? Are you able to understand that what is RIS system?
Yes, sir.
Please say yes or no so that I can proceed.
Yes, sir. Yes, sir. But the main issue is how to implement, how to integrate all this. Because machine learning normally implemented using Python programming, and the wireless sensor network application, I think it is through network simulator. So how to integrate all these environments, two environments, and apply the machine learning algorithms?
So you basically see that we are having an RIS controller which is supplying certain feedback from the RIS. So with the help of this RIS software defined control radios, you are able to control the phase of this elements. Okay, so you are having an electronic circuit. For example, suppose you are working, you are in the lift. Suppose, so what you will basically do, you will press certain button, and the button will generate some of the logics, and accordingly you will reach to a particular floor. So in similar way, this is having a feedback path, and accordingly you will basically control the phase of the RIS element, which will help you to improve the signal strength at the receiver. Now, as part of the implementation, if you are asking, then hardware implementation so far I have not done. But in the software, what you can do, you can just understand that you are having certain reflection coefficient, and you are able to modify those reflection coefficient by the help of some of the machine learning models. If you are able to get the correct value of the reflection coefficient, then it means you are able to successfully control the RIS panels. Are you able to understand?
Yes, sir. Yes. So, means first we need to integrate through some network simulator, get the result, then we can use that result in machine learning algorithm for training and testing for implementation of the machine learning algorithm.
Exactly.
Okay, sir. Thank you.
So now, one research paper I just want to discuss with you all, that is published by HB Poor in 2022. And the system model, what kind of system model they have taken, that is presented in front of you. This is the base station, this is active RIS panel, and this is the K number of users. Now, what they are doing, they are taking line of sight scenario also. Line of sight means directly base station is sending the signal to the user, and they are also getting the signal from the active RIS panel also, reflected signal. So this is the LOS signal, and this one is an LOS signal, non-line of sight signal. This one is line of sight signal. So they are having M antenna base station, which serves K single antenna users simultaneously with add of an element active RIS. Now, they have taken two scenarios. In one scenario, what they are doing, they are taking 4 users. You can say this is 4 users. This one is the base station. This one is the location of RIS. The same structure they have used over here. Only the difference is, in this case, the LOS condition is weak because they have placed the trees. If the tree is lying, then the line of sight condition will be poor. And in this case, there is no tree, so the line of sight condition is stronger. So they have written here weak, and they have written over here strong. Now they want to do the analysis on the effect of RIS when they are going to incorporate RIS. That what is going to happen. Now you see that in the first case, so there are certain parameters which need to understand, which they have taken into the consideration. One is the user is located at distance L from 0 coordinates. So this distance is L comma 0 in 2D coordinate system. This is 0 0. This is L comma 0. Now this RIS is placed at 300 meter comma 10 meter 2D coordinate system. Base station is placed at 0 comma minus 60 meter location, and the number of reflective elements, they are denoted by capital N, that how many reflective elements are going to be considered over the RIS panel, that is denoted by N. Okay, so now we will understand this. So you see that the result is something like that, they are going to vary the RIS element number on the horizontal axis. So number of reflective elements means over the RIS panel, how many number of reflective elements they are going to consider, and asymptotic receiver and SNR, they are doing the analysis of signal to noise ratio. Now you can see that N is equal to 256. They have particularly done the analysis at this particular level, that what difference is going to be observed. Now you can see that as the number of reflective elements is going to increase, the SNR value is going to increase. Means as you are going to increase the number of reflective elements over RIS panel, you are getting improved signal to noise ratio at the receiver. And that is going to be valid for both passive RIS, means this is blue one is the passive RIS, and the red one is the active RIS system. So in case of both systems, if you are going to increase the number of reflective elements, then the signal to noise ratio value is always going to increase. But the major concern is, in comparison to passive RIS system, active RIS system is giving you better signal to noise ratio, and at N is equal to 256, almost the difference is 40 dB. Okay. In the second part, you can see that further, if you are going to increase this, you are going to do the analysis of N is equal to 2.5 into 10 to the power minus 6. Means, if you are going to increase the number of reflective elements with a very large value, then what is going to happen, that at a point of time, passive RIS system is going to perform better than active RIS system. Okay, and why this is happening? This is happening because of the self-interference mechanism, self-interference phenomena, which will take place in case of the active RIS system, that will not occur in case of the passive RIS system. Okay, so certain observations are there. So this is asymptotic SNR as a function of the number of RIS elements n for different ranges of n. We can observe that when n ranges from 10 to 1000, the user's achievable SNR is 40 dB higher in case of active RIS added system compared to passive RIS added system. Only when n is equal to 2.5 into 10 to the power minus 6 becomes the performance gain achieved by the passive RIS comparable to that achieved by the active RIS system. So this is very crucial observation. The second observation, what they have done, sum rate analysis. So sum rate analysis, now you can see on the horizontal axis, we are not going to vary the number of reflective elements. We are going to vary the distance. Means how much distance away the users are going to lie. So as the users are going to lie far away from the base station and RIS surface, then definitely the sum rate means how many number of bits per second per herd the transmitter is able to successfully transmit to the receiver. This analysis is highlighted over here. So you can see that as the distance is going to increase, that sum rate performance is going to decrease. Sum rate performance is going to decrease means we are not getting better performance if the distance between transmitter and receiver is going to be large. But the primary concern is here that what is the difference, what difference will come in case of the active and passive RIS system. So you can see that the active RIS system, which is denoted in red color, and the passive RIS system, which is denoted in blue color, they are having a major difference. Means in case of active RIS system, we are having very good sum rate performance in comparison to passive RIS system. And these two curves, black and pink one, they are denoting that if we are going to do the random phase shift and without RIS system, so you can see that if we are not going to use RIS, then the performance is more worse. And if you are going to use RIS with random phase shift, then also we are not able to get better performance. It means that if you are going to apply the RIS, then how you are controlling the phase of individual reflective elements, that also matters a lot. Okay, so this blue curve is indicating that when you are going to control the phases of the reflective elements in passive RIS system, then you are getting slowly improved performance. But if you are going to use this active RIS systems, mean active reflective elements, then the system performance is going to improve at a large extent. And this is the scenario with weak direct link, means when the trees are going to lie between the transmitter and the receiver. And this is the scenario in case of the strong direct line of signal, means there is no tree lying between transmitter and receiver. Then what is going to happen? If there is no tree, then the sum rate performance is going to increase very in a very nice manner. And what you are going to observe, the sum rate performance is very good, even in the without RIS system. So I believe that these two curves are clear to you. Please answer my question, yes or no.
Yes, sir.
Please say yes or no. Otherwise, I will feel that I'm just telling and there's no, you are not able to understand. So slowly, like when you will be able to understand this, the concept of RIS and the advantages of RIS, then we will jump into the machine learning, that what machine learning is basically doing over here. Are you able to understand this?
Yes, sir. Understood.
I'm not able to listen.
Yes, sir. Yes, sir.
Okay. Thanks. So the same analysis you can see is that sum rate analysis, only the difference is that we are now changing the distance. What we have taken on the horizontal axis, we have taken earlier distance, now we are taking transmitted power. So obviously as the total transmit power is going to increase, the sum rate performance is going to increase. But in case of active RIS system, we are getting better performance in comparison to the passive RIS system. And this is with the scenario of one, that is weak direct link, and this is the scenario 2, that is a strong direct link. Now, this is the number of RIS element. If you are going to change the number of RIS elements, then what is the effect on the sum rate analysis? And this is the weak direct link scenario, and this is the scenario 2, that is a strong direct link. So you can see in this case also, you can see that the sum rate performance of the active RIS system is very good, and the sum rate performance of passive RIS system is poor in comparison to active RIS system. But in case of strong direct link, you can see that all these curves are going to be shifted slightly upward. Means the line of sight is helping us to improve the performance of the sum rate. Okay. Now, so far we are able to understand that always this strong line of sight scenario is going to help you to improve the performance of the system. But this curve is demonstrating that due to certain regions, your passive RIS system will perform better than active RIS system because of the self-interference mechanism according to the active RIS system. So you can see that this is corresponding to scenario 1 with a direct link, and this is corresponding to scenario 2 with a strong direct link. So you can see that self-interference factor, this green curve is denoting active RIS with no suppression. Orange one is indicating active RIS with SI suppression, and red one is indicating active RIS ideal case. So in case of ideal case, of course, the sum rate analysis is going to be very good. But in case of SI suppression, as the self-interference mechanism is going to take place, then this sum rate performance is slowly decreasing. But if you are not going to apply the over active RIS system, this suppression mechanism, then what is going to happen? This performance of the sum rate is going to even worse than passive RIS system. So this is in case of the weak direct link, and this is in case of the strong direct link. You can see that if you are not going to apply any suppression, then the performance of this active RIS system is going to be very worse in case of the due to self-interference mechanism. So far, like in these curves, whatever the curves we have seen, here we are always saying that active RIS system is better, active RIS system is better, active RIS system is better, active RIS system is better. But in this case, it is denoted that yes, active RIS system is having its own disadvantages due to self-interference mechanism, and that is illustrated in this particular slide. Now, we are so far able to understand that this active RIS system is very helpful to us, and if we are able to address the problem of self-interference mechanism by this active RIS system, then we are able to address the problem of wireless communication. Now, what I just want to highlight over here that what are the advantages of active RIS system is it can amplify the incident signal. It is having low cost architecture, and it enhances the network's SNR. And the challenges are reflecting matrix optimization are the challenge and requires accurate channel information. And with the help of multi-active RIS in IoT network, it mitigates the multiplicative path loss. It helps us to low-cost data routing, and it reduces data latency. So, what kind of system we have taken into the consideration, that is shown to you. Now you can see that suppose this is an IoT device, and this is the base station. Now, if you want to transfer the data directly to it, because of this tree, you are not able to transfer the data. Because of this will create obstacle. Now you are using this particular RIS, and this RIS is again transmitting the signal to this RIS, and this RIS is transmitting the data to this particular IOD. So our goal is to compute the optimal path through which you will reflect the signal so that the signal will reach to the destination, and we will be able to improve the SNR performance over the device. So for that sake, we have used a framework. So framework is we are measuring the latency. So our goal is to improve the SNR performance over this device, and we have to transmit the data in a faster mode also. Means minimum time with improved signal to noise ratio, we have to transfer the data to the IODs. Now for that sake, in this particular mathematical formula is highlighting sorry, this mathematical formula is highlighting that how you will compute the latency. So so first you understand that what is the meaning of RP. So RP means the reflection matrix of pH active RIS. If suppose there are p number of reflective elements over a RIS, then alpha 1 is the amplification factor, and theta 1, theta m, they are the phase shifters. So individual reflective elements is denoted by alpha and P. Yes.
Due to too much reflection, whether the noise.
What is it? Yeah, you are able to listen me? Are you able to listen me?
Yes, sir. Hello.
Yes, yes.
Whether it is audible?
Yeah. Hello? Something you are asking?
Yes, yes. I am asking about the reflection, number of reflection. Okay. So if the number of reflection increases, then definitely the noise will also increase. And just by considering the SNR value, whether it will produce a optimized result.
It will means like what we are doing, that we will understand from this particular formulation. You can understand like what we are basically doing. As you are telling that as the number of reflections will increase, the noise will increase. Not only noise, it will also incorporate more delay. Do you agree with me?
Yes, sir. Yes, sir. Definitely delay will be there.
Delay will increase. So what we are going to do, we are making an objective function, and that particular objective function is the function of alpha, t and m, where you can see that alpha is the attenuation factor associated with the reflective elements, t is the delay, and m is the number of reflective elements. So this is the total delay, and what we are basically going to do, we are trying to minimize the delay. We are trying to minimize the delay, and the delay is giving us that what should be the attenuation factor, optimal attenuation factor, and what should be the optimal path through which we should transmit the data. While we are minimizing this particular delay, we are also considering that what should be the minimum number of bound on the reflective elements over the individual RIS, what should be the bound on the attenuation factor, what should be the bound on the phase shift, what should be the power consumption bound on the RIS surface, and the signal to noise ratio threshold should always be greater than a certain threshold. These are the constraints we have considered while solving this particular problem. So what you are asking, that noise will be added, of course noise will be added. Yeah.
Or restrict the boundary.
Can you speak slowly? Yeah. Can you speak again? So you are telling that how to compute these things, right? You are asking this?
Yes, sir. Yes, sir.
So basically, we are using machine learning for that. So at least so far, I have not told you anything about machine learning. So far, I have just told you about wireless communication, RIS, and what is the problem. Now we are jumping to the this machine learning. So this is the problem in our hand. Now, what we are basically going to do, we are going to do this upper bound on this upper bound on the optimal number of active reflective elements. So for that purpose, we have developed computing optimal number of reflective active RIS elements. So for that, what we are going to do, we are supplying certain input values, that M, MK, alpha max, all those are input values, and output is the upper bound on the number of active reflective elements. And what we are going to do, at each iteration, we are going to compare the signal to noise ratio. If the signal to noise ratio is, we are able to get that particular level of this signal to noise ratio, then we are going to increase the number of reflective elements. And we are, in this way, we are achieving that what should be the upper bound on the reflective elements. And beyond that, if you are going to do, then we are going to reduce the signal to noise ratio, and we will stop over there. So here also we are not using any kind of machine learning mechanism, but you can see we are using Q learning framework to compute the shortest path. Now, shortest path, how you will compute this algorithm, if you will try to understand, you will not get this algorithm. You can understand at least, I believe that you know Q learning, this framework. How many of you are aware about Q learning? Anyone is aware about Q learning? No.
Yes, sir. It is a type of reinforcement learning.
Yes, it is a type of reinforcement learning. So basically in Q learning, what is happening? You are having agent, you will take certain action, you will get certain reward, and your ultimate goal is to maximize the cumulative reward. Okay. Now, what is happening here? Our goal is that we are getting optimal Q star. We are getting optimal Q star. So what basically we are doing, on individual RIS, we are selecting that we should transfer the data to which RIS, so that I will get minimum delay, we will get maximum SNR, and this process will be iterated for all the intermediate steps. And the intermediate steps, which is giving us the best Q value, the best reward value, cumulative reward value, that we are selecting as the best path, and that is returning us the optimal path, that is giving us the optimal path. So this is data routing in multi-RIS assisted IoT network, and we are getting the best optimal path in this way. So what you can understand right now, that how we are using Q learning framework to address this particular problem. You can understand that Q learning is basically a kind of reinforcement learning, where agent you can understand as a message. You can also take that a message is going to one RIS, then after reaching to that RIS, it will take the decision that next RIS, which RIS I should select, so that I will experience minimum delay and I will experience maximum SNR I will be able to achieve maximum SNR while reaching to the destination. Okay, so in this way, you are making the reward in terms of latency and SNR, and you are taking the action that which RIS I should move next. So that so action is its movement, and reward is in terms of latency and the SNR, and agent is your message. And cumulative reward is overall accumulation of all the rewards, and that accumulation of all the rewards is giving you the shortest path or the optimal path. Are you able to understand this?
Yes, sir.
So for the performance evaluation, what we have done, we have taken a environmental condition. You can see that this is the experimental condition. We are taking n is equal to 200, p is equal to 10, one access point we have taken. This is the network size. All those things we have taken, and we have compared. This our proposed method with a random RIS route selection, Dijkstra's route selection, and cooperative multi-beam routing method. These three methods we have compared our proposed method, and what we are getting, you can see that our proposed method, this is the data transmission latency with number of IODs. As the number of IODs we are increasing, the proposed method is giving the minimum latency in comparison to other existing methods. And if the number of reflective elements are increasing, then also the data transmission latency in case of the proposed method is quite lower in comparison to other existing method. So the methods with which we have compared, that is random RRS and Dijkstra's and cooperative multi-beam, and you can see that the performance of the proposed method in terms of the latency, either we are increasing the number of reflective elements, either we are increasing the number of IODs. In both cases, our proposed method is experiencing lower data transmission latency in comparison to other existing method. So that is with the help of Q-learning mechanism, we are able to address this particular problem. Now coming to this data transmission latency when we are going to vary the IOD data size. So as that IOD data size is going to increase, the data latency of course is going to increase. But if you will compare with the passive and active RIS system, then the active RIS system is having very low value of the data transmission latency in comparison to passive RIS system. And if you will do the complexity analysis, then you can see the only disadvantage is that the proposed method is having higher time complexity in comparison to other two methods, that is coordinate MBR and Dijkstra's SRS. However, in case of random RRS method, our method is having lower complexity. So what is the reason of higher complexity? Because your method need to identify that which relay RIS I should use next for the data transmission. That is the reason that you are having more time complexity. And the reward is, you can see as the number of steps training you are going to increase, the reward is almost getting saturated with the number of steps. So the average reward is plotted in the using red line. However, the instantaneous reward is very fluctuating, too much fluctuating, and we are getting almost saturated average and instantaneous reward with varying number of steps. So this was the first work. Second work, I just want to, actually I'm also tired, so I will quickly tell you that what exactly the problem is. In this particular paper, this is the second work. In this particular paper, what we are basically doing, we are using again RIS, and we are on this particular RIS panel, we are identifying the optimal group of reflective elements, and with the help of grouping, we are improving the performance of SNR over the devices. So grouping is basically we are using channel, some concept of channel coefficient correlation mechanism, and we are doing the grouping of the RIS so that we will be able to improve the SNR. That is the concept of this particular paper. I'm not going to So you just read this one, that the proposed method groups the reflective element to reflect the incident signal. This grouping is based on the joint common group phase shift and channel correlation between reflective elements. An optimization problem is formulated to minimize total latency with respect to the received power and RIS reflection matrix. An optimization problem is formulated to minimize the data transmission latency. Two novel algorithms are proposed to solve the formulated problem. Due to the coupled nature of constraint, the optimization problem is non-convex and is solved using the Q-learning. The performance of the proposed method is compared with benchmark methods, taking various network parameters into account. So this is the problem formulation. In this case, you can see that what we are going to do, we are computing optimal groups of the reflective elements, which is helping us to minimize the latency. So latency is going to be minimized with the help of this. We are having certain constraint that within a same group, we are having the common phase shift. We are having certain limitations on the power consumptions, and we are having certain limitations on the reflection matrix. Sorry. So this is the problem formulation, and what is the result? What we have got, you can see that the proposed method is giving us the better SINR performance in comparison to other existing method. Data latency of the proposed method is also very good in comparison to other methods. If you are talking about average reward, then average reward, we have done the analysis over 3 network conditions. So network size 1, network size 2, network size 3. And if you are going to vary the number of reflective elements, then average reward is going to be almost saturated in all 3 cases with the number of reflective elements. And for all 3 cases, you can see that they are almost following the same pattern. So this is the average reward, and this is the time complexity analysis. So time complexity analysis of the proposed method, only the disadvantage is that the time complexity of the proposed method is high in comparison to other existing methods. So this is the disadvantage of the proposed method. Otherwise, we are having very good improvement in terms of SINR, in terms of the data latency. The performance is quite good. Only the challenge is that we are getting poor time complexity. So as a conclusion of this presentation, what I can conclude, that multiplicative path losses between access point and Internet of Things devices are mitigated with the help of active RIS system. You are able to very well understood that why this active RIS elements is beneficial in comparison to passive RIS system. A bound on the optimal number of reflective elements is computed. An optimization problem is formulated to minimize the data transmission latency. 2 novel algorithms are proposed to solve the formulated problem, and a novel method of RIS elements grouping in the RIS assisted IoT network is proposed. And as part of, you can see that extension of this particular work, what you can do if you want to extend this particular work, distributed machine learning algorithms for the formulated problem over a more complex network scenario can be explored. So this is as a part of future work. You can use this distributed machine learning algorithm. So far, we have not used this one. We have so far used a centralized machine learning framework, that is reinforcement learning framework, to identify the relay RIS to transfer the data. So I just want to conclude over here because I'm completely tired now. So if you are having any questions, you can ask me. Otherwise, we will stop over here. So if you are having any specific question, you can ask me. Else. Okay. So you don't have any specific question, then I think we should switch off. We should close the session. If you have any question, you can ask me, else I will close.
Thank you, sir. Nice presentation. So if another session could be taken for implementing such applications, then it will be better.
So it would be nice. It would be nice if you can write to the organizing team to conduct that particular session, and if they will say to me, they will ask me, then I will definitely conduct another session.
Sure, sir. Thank you.
Okay.